Welcome pre-calculus students to the review sheet help video. This is probably the wimpiest of all wimpy review sheets you'll ever have, but I'm glad that it'll be easy for you and not as long as most of them. Please turn your books to page 594 if that's where you're at on the review sheet, and let's go ahead and get started with numbers 61 through 68. I am going to go fast. Of course, you can always rewind or pause the video if you need to. Okay, numbers 61 through 68. Hold on one second here. Guess I should turn on the Memo pad. There we go. Number 61 through 68, if you'll look at the directions, they say solve, finding all solutions that fall between, and they give a domain that looks like this, 0 and 2 pi. Now what that means is your answers have to be in radians because your domain was in radians. Now I would encourage you to solve this regularly in degrees, and then when you're all done, just simply convert your answers over to radians. That would be my suggestion. Let's go ahead and solve our first equation here. Numbers 61 through 68 are all trigonometric equations. First of all, I notice that I have just a sine and nothing else, so I'm going to get sine all by itself. So I divide both sides by 4. Divide both sides by 4, like this and like this. Now, I don't want sine squared, I want sine, so I'm going to take the square root of sine squared. If I do that, I'm left with sine. But if you take the square root of one side, you must take the square root of the other side. Okay? Notice the plus minus, very, very important. And now we do know the square root of 1/4 because the square root of 1 is 1 and the square root of 4 is 2. Don't forget your plus minus. So what we have done basically, students, is we have got our equation all the way down to this right here. And now I'm going to erase this to give me some room to work with. So I'm looking for an angle that when I take the sine of that angle, it gives me 1/2. Now the first thing I would do is I would look at my table here and see if I have one of my special angles, and I do. There it is. The sine of 30 gives me 1/2, the sine of 30. So I know that I want positive 1/2. Oh, and look what else, negative 1/2. So I'm actually going to have to draw my triangles in all 4 quadrants, okay? And in every triangle, I'm going to go ahead and put 30 degrees, okay? So I go from here to here, so one answer would be 30 degrees. Then you always stop at the hypotenuse, okay? So I go from here and I stop here. That's the hypotenuse. Here's your right angle right here. So that would be 150 degrees. And then here's my hypotenuse right here in this triangle. So I'm going to go from here to here, and that would be 210 degrees. And then I'm going to go from here all the way to here, and that would be 330 degrees. Okay, so with that in mind, now let's quickly put these into radians. And let's see how to do that real quick. Let's see, 30 is, I know 30 is pi over 6, so there's 1. 150. Now remember, I'm not going to convert all these for you. I'm not going to show you. You should know by now how to do this. You take 150 and you multiply it by pi over 180. Okay, and if you do that correctly and reduce, you'll get 5 pi over 6. Okay, 5 pi over 6. So that's my next one. And then my next answer would be 7 pi over 6. And then my next one would be, let's see, it would be 1, 5, 6, it'd be 11 pi over 6. 11 pi over 6. There you go. There's your 4 answers. Not too bad. Moving on to the next one. Alright, number 62. Now in this problem here, I do notice that I have a sine and a cosine. And normally what you'd like to do is try to factor out a sine, which is what I've taught you to do in the past. The only problem with that is you have 2 different signs. Here you're taking sine of x, and here you're taking the sine of 2x, and that's no good. Okay, we can't have that. So we're going to have to make a substitution. If you'll look at your trig identities in your double angle section, you will see the sine of 2x equals 2 sine x cosine x. So I can substitute this out, okay? by putting a parentheses for it, and now this is gone, and in place of that I'm going to put 2 sine x cosine x, and then bring down your sine x right next to it, because this is all multiplication up here, and then minus cosine x equals 0. Okay, now let's continue on. I have 2 sine x cosine x times sine, so that would be 2 sine squared cosine x minus cosine x. Hopefully you all see where that came from. 2 sine cosine times sine is 2 sine squared cosine. Now I can factor. Notice everything is x's. Sine of x, cosine of x, cosine of x. So now I can factor, and notice both of these terms. Here's one term, here's the other one. Notice both of them have a cosine, so I'm going to factor out a cosine. And if I do that, I'm left with 2 sine squared x minus 1. Now let's check and make sure we're right. Cosine times 2 sine squared is 2 sine squared cosine. Cosine squared times negative 1 is negative cosine. Now we take each group and set each group equal to 0. So cosine x equals 0. That's one equation. And the other equation is 2 sine squared x minus 1 equals 0. Now here cosine is all by itself, okay? So we're good. I'm going to get that out of the way. This one's all taken care of. Cosine of x equals 0. There's really nothing more we need to do with that, okay? But this equation here, I'm going to have to do a little bit of work with this one here. For example, I'm going to add 1 to both sides and then divide by 2. So now I'm left with sine squared x equals 1/2. Do you see how I did that? Bring the 1 over and make it positive, and then divide by 2. Now I take the square root of both sides. If I take the square root of sine squared, I'm left with sine. And if I take the square root of 1/2, that's plus minus square root of 1/2. Okay? Now let's take this further, okay? I know the square root of 1. Square root of 1 is 1. But I do not know the square root of 2. So the square root of 1 is 1, so I do not have to leave the square root in the numerator, but the square root of 2 I don't know. Now you've learned how to rewrite this. We've done this many times. 1 over square root of 2 is the same thing as square root of 2 over 2. 1 over square root of 2 is the same thing as square root of 2 over 2. So with that in mind, now I have my other equation in which my trig function is isolated, okay? I'm going to pull this one here, and I guess I'll pull this one right down here. All right, so now we're ready. Let me pause and get a quick drink here. Now we're ready to solve each one. Let's do the cosine of 0 first. I think that'll be a little easier. Notice there's nothing on our table, and when we take cosine of one of our given angles, that we get out 0. And so we're going to have to use our calculator. If you hit second cosine 0, you will get 90 degrees. Now that tells me that's one of my axis angles. So when that happens, remember, you got to test all of your axis angles. So you got to test 0. We don't worry about 90. We already know that works. 180 and 270. So here we go. I'm going to take the cosine of 0, and I did not get 0. I'm going to take the cosine of 180, and I did not get 0. I'm going to take the cosine of 270, and I did get 0. So let me get my pen ready here. The two answers would be 90 and 270. If you take the cosine of 90, you'll get 0. If you take the cosine of 270, you'll get 0. Now, students, let's come back over to this one. Notice, unfortunately, let's first of all pull our table up again. Sine of 45 degrees, here it is right here. Sine of 45 degrees gives me square root of 2 over 2. Now, the only thing is, I have a positive and a negative. So once again, like the last problem, I'm going to have to draw my triangles in all 4 quadrants and put 45 degrees in each one. Now, it's really not that hard to do. I think you guys can see that, but we still have to do it. So I rotate up to the hypotenuse. One answer is 45 degrees. I rotate to the hypotenuse right here, and that would give me 135. I rotate all the way to the hypotenuse. That would be 180 plus 45 more. That's 225 degrees. And then I rotate from here all the way to here. That would be 315 degrees. Okay, so there's my 4 angles right there. Now, let's see if we can quickly convert these over to radians. 90 is pi over 2. There's one answer. 270 is 3 pi over 2. 45 is pi over 4. Let's see, 135 would be 3 pi over 4. 225 would be 5 pi over 4. And then 315 would be 7 pi over 4. So here's your other answer. So it looks like we have a total of 6 answers. But remember something I taught you the very first time we went over this. Whenever your original equation has 2 different trig functions, sine and cosine, you must check. I know it's a pain, guys, but you have to do this. You must check each answer in the original equation. Now, all 6 of these do happen to work, so we're fine, okay? But that doesn't always happen. You would have to type into your calculator sine of 2 times, I would use the degrees if I were you instead of the radians. So I would type in sine of 2 times 45 times sine of 45 minus cosine of 45 and hit enter, and you should get 0 because the right side is 0, so 0 equals 0. And you'd have to check each answer that way. Now I'm trying to save you time and tell you all 6 of these do work. On the test you won't know for sure, so you must check. Alright, number 63. Now I notice that I have all cosines, that's good, but I have a cosine squared and a cosine. So more than likely I'm going to have to factor, okay? So 2 cosine squared plus 3 cosine x, bring over your -1 and make it positive, equals 0. Now I've taught you in the past, I like to rewrite it like a quadratic, like this. And so we're going to factor a quadratic that has a lead coefficient of 2. So remember, you take this number times this number and you write it over here. 2 times 1 is a positive 2. What 2 numbers when multiplied together give you 2, when added together give you 3? A positive 2 and a positive 1. These 2 numbers multiplied give you 2, added give you 3. So you bring down your first term and you do not bring down your middle term. Instead of putting 3x, you put 2x plus 1x, which is the same thing as 3x, and I got the 2 and the 1 from these 2 numbers over here. Then you bring down your last term and then equals 0. Now we pull out what's common in the first 2 terms, 2x, and we're left with x plus 1. Let's check and make sure we're right. 2x times x is 2x squared. 2x times 1 is 2x. Here there's nothing really common except a 1, so we're going to pull out a 1 and we're left with x plus 1. Alright? Let's check our work. 1 times x is x, 1 times 1 is 1. Now your parentheses should match, and they do. So we have x plus 1, and then of course we're left over with 2x plus 1. So there we go. So we have factored this all the way down. Of course now we have to put our cosines back in, and it would look something like this. We would have cosine of x plus 1, and then 2 cosine of x plus 1 equals 0. So there we go, and now we're ready to take each parentheses and set each parentheses equal to 0. So cosine of x plus 1 equals 0. Bring the 1 over and make it negative. Cosine of x equals -1. Here we have 2 cosine x plus 1 equals 0. Bring the 1 over, make it negative, and divide by 2. Cosine of x equals -1/2. Alright, so there we go. And now let's quickly pull these up here. And we have our 2 equations to work from. Let's go ahead and start with this one over here. I'm going to pull my table up. Nowhere on my table does cosine give me a -1 when I take the cosine of an angle. But notice I do have 1/2, and that would be right here. The cosine of 60 is 1/2. So for this problem here, I'm going to have to use my calculator. And for this problem here, the reference angle is going to be 60 degrees. All right, so let's go ahead and use the calculator. We're looking for an angle right here. So I'm going to type in second cosine -1, and we're going to get 180 degrees. Right away I realize that's an axis angle, so I've got to check all of them. So the cosine of 0 does not give me -1, the cosine of 90 does not give me -1, and the cosine of 270 does not give me -1. So the only answer for this equation here is 180 degrees. Now let's come over here and use our reference angle. Remember, we want to use an angle so that we get out of -1/2. So where is cosine negative? Let's see, cosine is negative here, and cosine is negative here. So I will put a 60 here and a 60 here. Okay, I'm going to rotate from here to here, so one answer is going to be 120 degrees. And then I'll rotate from here to here, and the answer will be 240 degrees. Now, it looks like then we have these three answers right here. 1, 2, 3. You do have to convert your answers to radians, so let's try to do that very quickly. For 180 degrees, radians is pi. For 120 degrees, let's see, that would be 2 pi over 3, I believe. And then 1 1/3, this would be 4 pi over 3 for 240 degrees. So here's your three answers. No need to check these. The original equation had all cosines in it, and so we're totally good. And I guess I should check this in the book to make sure I'm right. And yes, we are looking really good. That is correct. All right, number 64. Now, this one here, really, guys, is pretty simple. I mean, it's already set equal to 0. You've got sine of x, sine of x. I'm just going to factor out a sine. So if I factor out a sine, I'm left with sine x minus 7. Let's check and make sure we're right. Sine times sine is sine squared. Sine times -7 sine x. So we take each group and set each group equal to 0. So sine of x equals 0. The other group would be sine x minus 7 equals 0. Bring the 7 over and make it positive. So sine of x equals 7. There we go. So let's quickly do some erasing here. We have our two equations that we're going to use. We can pull our table up. I don't think it will do any good. Nowhere do I see a 0 in the sine row, and nowhere do I see a 7 in the sine row. So we're going to have to use a calculator for both of these. Now, for sine of x equals 0, I'm going to hit second sine 0, and I get 0 degrees. So that tells me right away I have an axis angle. So I'm going to take the sine of 90, and that did not give me 0. I'm going to take the sine of 180, and that did give me 0. And the sine of 270 did not. So my other answer right here would be 180. Check and see if you want to. If you take the sine of 0, you'll get 0. If you take the sine of 180, you'll get 0. Now let's come over here. Let's use our calculator. I already know what's going to happen. When you hit second sine of 7, you're going to get undefined or no answer or no solution. And that's true. There is no angle that you can put in for x here that when you take the sine of that angle you get 7. It's just impossible. Okay? And I do know why. I'm not going to go into great detail except simply to say this. Sine is opposite over hypotenuse, and the hypotenuse is always the longest side in a right triangle. Thus the bottom of this fraction will always be bigger than the top. Thus this number right here has to be less than 1. But I'm just going to leave it at that for now. Anyways, if you type this into your calculator here, students, you will see that there is no angle here that works. So the only two angles are these right here. And so put these in radians, we would have 0 and we would have pi. There's our two answers, okay? No need to check those, and let's continue on. Number 65. Now notice here I have a cosecant and a cotangent, okay, students? And that's obviously not good. Whenever I see a squared and a squared, I think Pythagorean identities right away. And what I notice here in the back of my book, I notice that for cosecant squared, if you'll look at your Pythagorean identities, cosecant squared equals 1 minus, and just hold on, 1 plus cotangent squared x. I had to look myself there for a second. So cosecant squared x equals 1 plus cotangent squared x. So I can substitute this out, and that's a good thing to do because now my whole equation is going to have all cotangents in it. So 1 plus cotangent squared x minus 2 cotangent squared x equals 0. So there we go. Looking pretty good. Okay, now notice these are like terms. I have a 1, even though you can't see it, there's a 1 in front of the cotangent right here. Okay, so I've got a 1 cotangent squared minus 2 cotangent squared. They're like terms, so we can put these two together. So 1 minus 2 would be negative 1 cotangent squared x. Okay, and then bring this positive 1 down right here, positive 1. Now hopefully you see where this term came from here. Look at it again. These are like terms, cotangent squared x, cotangent squared x. So 1 minus 2 is negative 1. And now to be honest with you, look, all that we have is a cotangent, nothing else. That's it, cotangent squared, of course. So let's get this all by itself. So the first thing I would do is bring this positive 1 over, and when I bring it over, it's going to be gone, and I'm left with the negative 1. So now it's negative 1 cotangent squared x equals 0 minus 1 is negative 1. Now we divide both sides by negative 1, divide by negative 1, and these cancel, and we're left with cotangent squared x equals 1 because a negative divided by a negative is a positive. And then of course we take the square root of both sides. So the square root of cotangent is the square root of cotangent squared is cotangent, and the square root of 1 would be plus minus 1. Let me get out my eraser, and of course if you want to look at this again you can pause the video or back it up. I'm going to erase this to give me some room to work with. So now I've got a really nice equation to work with. I'm looking for an angle that when I take the cotangent of it I get either positive 1 or negative 1. So like usual, the first thing we're going to do is pull up our table, and hey, look at this, we do have one right here. The cotangent of 45 is 1. The cotangent of 45 is 1. So now I'm looking for a positive and a negative 1. Don't miss that. So I'm going to have to use all four quadrants. So cotangent is positive here. Cotangent is negative here. Cotangent is positive here, and cotangent is negative here. So we have to use all these. So 45 degrees was our reference angle. Let's toss that inside of every triangle, and now we're going to rotate around to the hypotenuse. So we rotate to here. So one answer is going to be 45 degrees, and then we rotate to here. So one answer will be 135 degrees, and then we rotate to here. One answer is going to be 225 degrees. And then we rotate to our last quadrant to right here, and one answer will be 315. Now, let's convert each one of these to radians. This would be 45 degrees would be pi over 4. 135 would be 3 pi over 4. 225 would be 5 pi over 4. And 315 would be 7 pi over 4. Now, if you remember, please don't forget to do this on the test, men. Here's your four answers right here, okay? Now look at your original equation. Notice we had a cosecant and a cotangent. It's always wise to check your answers, all four of them, one at a time to make sure they work. Now in this case they do all work, and usually they do, but you will always want to check to make sure that all of your answers work when your original equation had more than one trig function. Okay, let's take a look at number 66. Now, here's my problem. Yes, I have a sine, and yes, I have a sine. But notice one angle is 4x and one angle is 2x. So somehow I've got to get these worked out so that they have the same angle. Let me get a drink here real quick. Hold on. Now, here's my suggestion. I'm thinking double angle identity. Now this is going to be really confusing, so I hope you'll really put your thinking cap on here and really watch. Okay, watch this. If you'll look at your double angle identities, we have sine of 2x equals 2 sine x cosine x. Now, it's not going to do me any good to put this in for this right here, sine of 2x, because then I have sine of x, cosine of x, and I've still got a 4x over here. But here's what I'm thinking. Watch this carefully. Notice that I have sine of 2 times x. So whatever I'm multiplying 2 by, in this case I'm multiplying 2 by what? X. Do you see that? Whatever I'm multiplying the 2 by, notice that's what I put here and here. So whatever is here goes here and here, and you're like, well, yeah, duh, that's obvious. Well, let's apply that a step further. Let's take sine of 4x. Okay, sine of 4x, and I'm going to rewrite it so that I have a 2 right here. Now watch how I do this. I'm going to, instead of putting 4x, I'm going to put 2 parentheses 2x. Now that's fine. I can do that. It's totally legal. Do you see what I did? Sine of, here's my whole angle right here. My whole angle is 2 times 2x, okay? And what is 2 times 2x? 4x, so I didn't change anything. But now I'm trying to get you to see something. Up here, I was multiplying 2 times x, so I have an x here and an x here. Here I'm multiplying 2 times what? 2x, so I would not have sine of x. I would have 2 sine of 2x cosine of 2x. That's totally legal. In fact, that's what you're supposed to do in this problem. You're supposed to realize that you can rewrite 4x as 2 times 2x, and now what are you multiplying 2 times? You're multiplying 2 times 2x, so we put a 2x. If there's a 2x here, then we put a 2x here and a 2x here. Just like up here, if there was an x here, then we put an x and an x. So for sine of 4x, I can substitute 2 sine 2x cosine 2x, and then bring down your positive 2 sine 2x. Now, I know that's a little weird to do, and I hope that you're understanding that, but do you not see how that's helpful? I mean, that's really helpful. Now everything is, all of the angles are 2x, 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 and now I can factor out, well, they both have a 2 in common, this 2 and this 2 out front, and they both have a sine in common, so 2 sine 2x, and then parentheses, and then equals 0. So let's see, we're left over with cosine of 2x plus 1. Now let's see if that's right. 2 sine 2x times cosine 2x is 2 sine cosine. 2 sine times 1 would be 2 sine 2x. So we're good. So I take my first group, and I set my first group equal to 0. 2 sine 2x equals 0. And then my other group, cosine of 2x plus 1 equals 0. Now I divide both sides by 2, not this 2 here, but this 2 over here, and I'm left with sine of 2x equals 0. Over here, I'm going to bring the 1 over and make it a negative 1. So I'm left with cosine of 2x equals negative 1. Okay? So I've got my equations simplified down pretty nicely here. Let's move these up top to get a little bit of room to work with. And let's pull up our table real quick. I don't think it's going to help us. Nowhere do we see a 0 in the sine column, and nowhere do we see a 1 in the cosine column. So it's not going to help us to use our table. Now, if it's not going to help us to use our table, we're going to have to use our calculator. So we're going to have to find out what angle would I put in here to get 0. So second sine of 0 gives me 0 degrees. So I know one answer is 0. It's really not an answer though, so hold on, don't get ahead of yourself here. And then the other one would be 180. As soon as you see that one of your angles is 0, you want to test all of your quadrant angles, and sine of 180 is 0. Now we want to see when cosine gives us negative 1. So I'm hitting second cosine negative 1, and I'm getting 180 degrees. Okay, 180. Now, that's an axis angle, so I've got to check all the others. So cosine of 0 did not give me negative 1, cosine of 90 did not, and cosine of 270 did not. So here's the answers I've got to work with. Now usually you think you're done, but hold it. Students, I don't want to know what this angle is. I want to know what x is. That's always your goal in an equation, is to solve for the variable. So this whole angle right here, this whole angle has to be what? 0 degrees. But not necessarily x. I want this whole angle to be 0. So I've got to say 2x equals 0, and then divide both sides by 2, and x equals 0. So far so good. We're fine. Now I want this whole angle to be 180 degrees, right? I want this whole angle here to be 180 degrees. So I've got to set 2x equal to 180, divide both sides by 2, and x equals 90, which makes sense, guys. If x is 90 right here, then 2 times 90 is 180, and the sine of 180 is 0. I got some bad news. We're not done. We've got to keep going. Remember how you can always add 360? We want all of our x answers. We want every single x answer that falls between 0 and 2 pi, or in other words 0 and 360. We got to keep going. See this 0 degrees right here? I can add 360 to that. In other words, let me see if I can erase this very carefully. That wasn't very carefully, but it'll have to do. In other words, if you don't believe me, trust me, type in the sine of 360 degrees and you'll get out 0. So this whole angle could be 360. So now I've got to take 2x and set it equal to 360 and divide both sides by 2, and x equals 180. Now, I'm going to take 180 and add 360 to it, and I'll get 540. Now look, if you don't believe me, then go ahead and take the sine of 540, and you will see the sine of 540 degrees is 0. Okay? So, what would x be if the whole angle is 540? Well, let's see. 2x equals 540, divide both sides by 2, and x equals 270. Well, I'm still good. Look at all 4 of my answers. They're all between 0 and 360. So now I take 360 and add 360 to that, and I'll get 720. And believe me, that when you divide by 2, that's going to go too far. So here's your 4 answers here. Now, let's come over here. Students, please use common sense. Why would I use 180 and start all over again? I mean, I can if you want to, but we already used 180 over here. Let me show you what I mean. We're saying the cosine of 180 equals -1. So I don't want to know what the angle is. I want to know what x is. So I'm going to say 2x equals 180. Divide both sides by 2, and we get 90. We already did all that work over here. And then you would take 180, add 360 to it, you'll get 540. And so basically what I'm saying to you is the cosine of 540, the cosine of 540 is -1. And that's true. Type it in if you don't believe me. And so if that's true, if the whole angle is 540, then I set it equal to 2. Divide both sides by 2, and x equals 270, which is the same answer I got right over here also. So there's no need to be repetitive. My 4 answers are right here, 1, 2, 3, 4. If you convert those to radians, you would have 0, pi over 2, pi, and 3 pi over 2. Okay, so there's your 4 answers. No need to check them. The original problem had all sine, and that's it. Okay, that is a really tough problem, and I know that. You might want to watch it 2 or 3 times just for your pleasure and enjoyment. All right, number 67. Now this one's going to be really, really tough. Let me tell you what my mind goes through when I look at this. Okay, other than of course crying. First of all, I notice there's no substitutions I can do for sine or cosine. Nothing that's going to help me. Secondly, I noticed that I have a sine and a cosine, so it's going to be really hard to just solve this. So I noticed they both had a 2. So when I solved this, I factored out a 2, and I was left with this. Sometimes you have to play around with these a little bit and just kind of see what happens. So then I said to myself, okay, self, I can divide this side by 2, so these cancel, and I'll divide the other side by 2. So then I was left with this. Cosine of x plus sine of x equals square root of 2 over 2. And I thought, okay, now I did learn once that I can square, and that means take this whole side and square it. I can square one whole side as long as I square the other side. Now, remember, if you square two terms, that's like cosine x plus sine x times cosine x plus sine x. That's cosine times cosine, cosine times sine, sine times cosine, sine times cosine. That's a lot of work, but I'm going to do that for you very quickly. If you did all of that, you would get this right here. You would get cosine squared x plus 2 sine x cosine x plus sine squared x equals, now if you square this fraction, that means you square the top and the bottom. When you square the square root of 2, you just get 2. And when you square 2, you get 4. Remember, anytime you square a square root, you get the number on the inside, excuse me. So you square a square root, you get 2, square 2, and you get 4. Now, we're doing really well. I mean, we're cruising right along. The next thing that I noticed, let me get a quick drink here. The next thing that I notice here is I have a sine squared plus cosine squared. In other words, if I wanted to very quickly, let's see if I can do this without making too much of a mess. If I wanted to rearrange the order of these terms, if I wanted to put that's really funny, isn't it, guys? All right, let's see if I can do this right. Well, anyways. If I wanted to rearrange the order of these terms, notice I have sine squared plus cosine squared, and that's 1. Look at your Pythagorean identity. Sine squared plus cosine squared is 1. So now I'm left with 2 sine x. And you might say, well, Mr. Earhart, when you do it, I understand it, but I don't think to do all this on my own. Well, I understand, but it just takes practice, okay? And just kind of looking and figuring things out. Sine squared plus cosine squared is 1. Notice 2 over 4 is 1/2. I reduced it. And now there's a trig identity I can substitute in for 2 sine x cosine x. Look at your double angle identities, and you will see that sine of 2x equals 2 sine x cosine x. So now this whole thing is gone, and I have this plus 1 equals 1/2. Now I'm obviously running out of room, so I'm going to do a little erasing here real quick. And let's see if we can't move this up top. Now our goal, of course, is to get sine all by itself. So I'm going to bring the 1 over and make it a -1. So when I do that, I'm left with sine of 2x equals, bring the 1 over, it's a -1, that would be -1/2. So there we go. I broke it down. Now let's take a look at our table, and here it is right here. When I take the sine of 30, I get 1/2. Now, the only problem is, notice, well, let me go ahead and write that. So I'm dealing with 30 degrees. Okay. So I want, though, a -1/2. So sine is negative here, and sine is negative here. So I'm going to put a 30 and a 30. So I start here, and I rotate to here, and that would be 210 degrees. So there's one almost answer, not quite. And then I rotate from here to here, and that would give me 330 degrees. Now normally you're finished, guys, I know that, but we don't have an x here. It's like the last problem. We had this 2x and this 2x. We had to do all this work. Unfortunately, it's the same thing. We don't have sine of x equals -1/2. Thus, my answers are 210 and 230. We don't have sine of x. We have sine of 2x. So this entire angle right here is 210 degrees. If you don't believe me, go ahead and type in sine of 210, and you'll get -0.5. So the whole angle is 210. The only problem is I want to know what x equals. So I'm going to have to take 2x and set it equal to 210 and divide by 2. And when I do that, I'm going to get 105 degrees. So there's one answer. Now, 330 is another answer. And if you don't believe me, type it in. The sine of 330 is -0.5. So the whole angle is 330, but I want to know what x is. So I've got to take 2x set it equal to 330 degrees, and then divide by 2. And if I do that correctly, I should get 165 degrees. 165 degrees. Okay? Now, we're not finished. Look, if 210 was one of my reference angles, add 360 to that, and you're going to get 570. Okay? And trust me, if you take the sine of 570, you will get negative 0.5. All right. So if the whole angle is 270, then I'm going to have to take 2x, set it equal to 270 or 570, excuse me, divide both sides by 2, and you'll get 285 degrees. Well, we still haven't gone over 360, so we're doing good. Okay. Now let's come over here. If 330 was one of the angles that I could take the sine of, add 360 to that, you're going to get 690. And trust me, if you take the sine of 690, you will get negative 0.5. All right. So if the whole angle is 690, I've got to know what x equals. So I'm going to say 2x equals 690 divided by 2, and x equals 330 degrees. Excuse me. 300, that's not correct. I apologize. Let's see, 345 degrees. 345 degrees. Okay, so there's my answers. Now I have to convert each of those to radians. I'm not going to take time and show you how to do that. Oh, you know what though? Hold it. There's something else you got to remember. When your original equation has two different trig functions, you got to check your answer. And also, don't ever forget this, guys. When you square both sides of an equation, sometimes you get extra answers, and we did square both sides. So because of that, we've got to check our answers. And when we do that, we realize not all of them work. And so let me quickly look here. I know two of these work. Let me convert these over to radians real quick here. 105 divided by 180. Okay, this one here, 105 is 7 pi over 12, and that one does work. So one answer is 105 degrees, and of course we want it in radians, so 7 pi over 12. So that's one of the answers. The other answer, I believe, I'm checking now, is, I believe it's the 345, but I'm going to see if it is. Yes, 23 over 12. Yes. So the other answer that works, so this one does not, and this one does not. The other answer that works is 345 degrees. And of course, if we have to convert that to radians, if we do, we get 23 pi over 12. Now, how did I know these didn't work? Well, check it and see, guys. We're saying x is 165. So right here, if you put 165 degrees and 165 degrees and type this whole side into your calculator, type in 2 cosine 165 plus 2 sine 165 equals, hit enter. It will not equal, I'm not sure what the decimal of the square root of 2 is. I will tell you in 1 second. 1.414. So if you type this whole left side in, you will not get 1.414. It doesn't work. And also if you use 285 up here, it does not work. So these are your answers here. They're the only ones that work. Okay, one more trig equation, and then we'll move on to the next page in our review sheet. When I look at this trig equation here, I notice that I have a tangent, and a secant. So somehow I'm going to have to make a substitution. I notice I have a squared and a squared. So for me, I think Pythagorean identities. And if you'll look at your Pythagorean identities, you'll notice that we have one that says secant squared x equals 1 plus tangent squared x. So if I can make that substitution for secant squared, then everything will be in terms of tangent, and that's a really big help. So I'm going to cross this off right here, and in place of that, I'm going to put 1 plus tangent squared x. Okay? Now, with that in mind, notice I have all tangents all the way across, and I have a tangent squared, a tangent squared of 1. So more than likely, what I'm going to want to do is get one side equal to 0, so I can try to factor. So I have 6 tangent squared. I'm going to bring over a positive tangent squared to this side, and when I bring it over, it becomes a negative tangent squared. So I have 6 tangent squared minus 1 tangent squared. That leaves me with 5 tangent squared. So this is gone. Next, I bring my 5 tangent x over. When I do, it becomes a negative 5 tangent x. And then I bring my positive 1 over, it becomes a negative 1. So it looks like I've got a chance here to factor, and I like to rewrite mine like this: 5x squared minus 5x minus 1 equals 0. And then I take 5 times negative 1 and I put the number right over here. 5 times negative 1 is negative 5. So what two numbers when multiplied together give me negative 5, but when added together also give me negative 5? Well, that's impossible. It can't be done. So guess what? This thing is not factorable. So we can't factor it. Now, we've not done all this work in vain. In fact, everything we did we had to do, but we can't factor it. So remember, we do have a quadratic equation here in a way we do. And I'm going to go ahead and use my quadratic formula. Now watch how I do this. A equals 5, B equals negative 5, and C equals negative 1. Now, the quadratic formula is negative b, so I'm putting a negative 5 in, so negative 5 would be a positive 5, plus minus the square root of, I guess I better put it up here so you can see it. It's negative b plus minus the square root of b squared minus 4ac all over 2a. So here we go. B squared, do that in your head, put a negative 5 in. Negative 5 times negative 5 is 25. And then I think we can do negative 4ac in our head. It's negative 4 times 5 times negative 1. So negative 4 times negative 1 is 4 times 5 is 20. So we get a positive 20. And then the bottom, or the denominator, is 2 times a, so 2 times 5. A is 5, 2 times 5 is 10. Now let's continue along. Next I would have 5 plus minus the square root of 45 all over 10. All right. Now let's go ahead and type that into our calculator and get out a couple decimals here, and let's see what we would have. We would have 5 plus the square root of 45, enter, divided by 10, enter. And so I would get 1.1708, and then I would type in 5 minus the square root of 45, enter, divided by 10, and I'm going to get negative 0.1708. Okay, so now that's not my answers. Please follow along. That's not my answers. That's just giving me the values that I can take the tangent of. So now, or that I'm going to set tangent equal to. So tangent of x equals 1.1708, and tangent of x equals negative 0.1708. Very cool, huh? So there we go. Now, I'm looking, by the way, I could pull my table up here if I wanted to. Nowhere in the tangent column is there going to be a 1.17 or a negative 0.17. So what I'm looking for here is what quadrant, or, I'm sorry, I apologize. First of all, let's go ahead and use our calculator. So second tangent of 1.1708 gives me an angle of 49.4. I'm just going to call it 49 degrees. So tangent is positive here, and tangent is positive here. So I'm going to put 49 degrees here and 49 degrees here. So I rotate up to here. That gives me 49 degrees. And I'm going to rotate from here to here. That would be 180 plus 49 degrees, which would give me 229 degrees. So there's my two answers. Now I come over here. Let's find the angle, the reference angle. I'm going to hit second tangent of negative, I'm just going to use the positive, and by the way, don't worry about this negative sign when you're trying to use a calculator here. We'll worry about the negative sign once we draw our two triangles here and here, because that's where tangent's negative. So I'm going to type in second tangent, and then don't use the negative sign, just use 0.1708. And if we do that correctly, 0.1708, would give me 9.6. So I'm going to say 10 degrees. So I'm going to put a 10 degrees here and a 10 degrees here. Okay, I rotate from here to here, and that would give me, of course, 170 degrees. And then I'm going to rotate from here all the way to here, and that would give me 350 degrees. Okay? So there we go. Now let's very quickly convert these over to radians. And this one here would be 49 pi over 180. And the next one would be 229 pi over 180. Both of those are non-reducible, so we cannot reduce them. Over here, we would have 17 pi over 18. And then here, 350 divided by 180. If you converted this to radians, you would get 35 pi over 18. Now there are your four answers, and by the way, notice in the original problem we do have two different trig functions, a tangent and a secant. If you checked all four answers do work. Okay? Alright, I hope this has been a help so far on this page. Let's go ahead and move on now to the next page on your review sheet, which actually I forget what it is. Let's go back up top here, page 670. So let's go ahead and take a look now at page 670. Let me turn over there in my book very quickly here. And I'm going to do two more problems and then stop the video, and we'll just call that part one. That'll give me a break and give you a break, and that's 9 problems. And then part 2 will also have 9 problems. Okay, number 7 says solve triangle ABC if possible. Now what I've taught you to do is to always get a picture of the triangle. It's very important to do. So there we go. And I'm going to call this A, this will be B, this will be C. So side A is 23.4, side B is 15.7, and side C is 8.3. So there we go. Let's go ahead and use the law of cosines, and let's see if we can't solve the triangle and find the missing angles. It does not matter which angle you solve for first. I'm going to go ahead and solve for angle A just because I feel like it. So way over here I've got to put my A squared, so 23.4 squared. And then of course I would have 8.3 squared plus 15.7 squared minus 2 times 8.3 times 15.7. Let me grab my calculator very quickly here and let me start typing. 23.4 squared would be 547.56 equals 8.3 squared would give me 68.89. And then 15.7 squared would be 246.49. And then 2 times 8.3 times 15.7, according to my calculator, would give me 260. So negative 260.62 cosine A. Now remember, this is all one term, so those have to stay together, okay? But I can definitely move this over, and I can definitely move this over, and change the sign. So let's do that very quickly. 547.56 minus 68.89 minus 246.49. 246.49, and I'm getting, if I'm doing this correctly, I'm getting 232.18 equals negative 260.62 cosine A. So let's divide both sides by negative 260.62, and I'm going to get a negative 0.890. I'm going to go ahead and put a 9, but it's 8756043 equals cosine of A. Let's go ahead and hit second cosine of that decimal, and you will get 152.9, so 153 degrees. So angle A would be 153 degrees. Okay, a little bit of a pain, but that's how you do that. Now let's go ahead and quickly find one more angle, and then we can find the third angle by just adding together and subtracting from 180. Let's see if we can get a little bit of extra space here. All right, here we go. Now let's go ahead and solve for cosine of B. Actually, you know what, students, I shouldn't have done that. I want to leave this up. Do you notice how I have all of these squares already right here for me? So let's go ahead and open another page, or let's actually do this. Let's see if we can't just maybe slide some of this stuff over. I'm telling you, it's really worth it to save time like this, okay? Because what we have is we've got a lot of work done for us already. I don't want to waste that. So here we go. Let's find now the angle of B. So cosine of B. So I come way over here, and look what I'm going to do, guys. Look, I'm going to put, normally it'd be B squared, but I already found B squared down here, and it was 246.49. That's why I didn't want to erase this at all. Okay, and then let's see, if I have cosine of B, then B goes here. I have A and C over here, so A squared would be 547.56, and then B squared, C squared would be 68.89. And slide this over and just get a little more room. And then right here it would be -2 A times C. Let me grab my calculator and take care of that real quick. -2 times A, which is 23.4, times C, which is 8.3, and that would give me -388. I'm going to squeeze it in here. That would be -388.44. All right. Now again, this is one term here, so keep them together. I can bring this over and I can bring this over. So let's see what happens very quickly when I do that. 246.49 minus 547.56 minus 68.89. I hope I'm typing this in correctly. I'm going fast. You get -369.96 equals -388.44 cosine B, and then divide both sides by, let's see, divided by -388.44, and you get out 0.952425085. So 0.9524. 0.9524. Notice it is positive because a negative divided by a negative is positive. Now with your calculator, very quickly, just hit second cosine of that decimal, and you'll get 17.7. I'm going to call that 18 degrees. So there we go, guys. Not too bad. So 153 degrees for angle A, 18 degrees for angle B. If you add these together, you get 171. So this has to be 9 degrees over here. Okay, there we go. One more and we'll take a break. All right, number 8. Solve the triangle if possible. Let's go ahead and just draw a little makeshift triangle here very quickly. A, B, and C. Angle B is 27 degrees. Angle C is 35 degrees. And little b is 19. Now here's what I've taught you to do. I've always said step 1, make sure you can solve the triangle. And I should have mentioned these steps in the last problem, and I apologize I didn't. But step 1, make sure you can solve it. So you need at least one side and 2 other parts, and we have that. Step 2, if you're given 2 angles, find the third angle quickly. So we can do that. 27 plus 35 would be 62. So that would be, I believe, 118 degrees. Let me check and make sure that's right. 118 plus 62. Yes, that is correct. So there we just found that third angle very quickly. Then step 3 says use law of sines if you can. And we can because we have a pair right here. Look, we have a pair. See that? And so our pair is going to be 19 over sine of 27. Okay? Now you choose whether you want to find side C or side A. I'm going to find side A over sine of 118 degrees. So if I cross multiply and then divide, I will see that A equals 19 sine of 118 degrees over sine of 27. Let me grab my calculator and type this whole thing in very quickly. 19 sine of 118 degrees equals, divided by sine of 27 equals, and I get 36.9, or in other words 37. So A has a length of 37. So now I can cross off this A and put 37. And now let's use law of sines. Well, actually what the step 4 says to do is for the rest of the problems now, use law of cosines. If you'll look at your steps, it says after you've done steps 1 through 3, the safe thing to do is use law of cosines all the way through, and it really is the safe thing to do. But that's usually in reference to, I didn't put this in your steps, but that's usually in reference to if you're trying to find an angle, because sometimes there's more than one solution and that kind of stuff. But since we're looking for a side, it would be okay to use law of sines. That's totally fine. You could use law of cosines too. Either way is fine, but I'm going to use law of sines. So I've got my pair right here. I'm looking for side C, so C over sine of 35. Well, let's cross multiply and divide. C would equal 19 sine of 35 degrees over sine of 27. Let me grab my calculator very quickly and type that in. 19 sine of 35 degrees and then divided by sine of 27 would give me 24.00480252. So basically 24. So C here is 24. So very good, not bad. We've knocked out half the review sheet right there. That'll be labeled part 1, and whenever you're ready you can go ahead and watch part 2, which will be downloaded at the same time this one is.